Hey, how's everyone doing? I'm waking up Mewbot here as we speak. So if you're in the chat, feel free to say hi. It's the start of summer session 2 today, and my contacts are going crazy. I cannot see. That's what's going on in my life. What is going on in yours? If you are here in the chat, feel free to say hey, because that is how Mewbot sees you. I'm going to disappear and try just, hey, Sierra, good to see you here. I'm currently vanished. My contacts, you ever had that morning where your contacts and just don't center on your eyes and you're just like, I am partially blind? Jessica, good to see you here too. Lindley, good to see you here. Sorry, I'm literally like, I am blind to begin with, and today is just one of those days. But good to see you here. What questions are there? We're gonna add some mods. Jessica, good to see you. We're just talking on Discord and all that great stuff. Check out the Discord if you haven't. What are people's thoughts on the Discord? Drop questions in the chat. But the Discord is a huge help, I believe. It's one of the quickest ways I've ever seen to communicate with people, where you can just instantaneously ask a question. It's just instant messaging back and forth. So huge thing. Michelle, good to see you there. And I'll tell everyone this. I was like, because we this is, kind of a conversation on here. I've had 2 eye surgeries. Count them. 2 eye surgeries. I had one at 2 and I had one at 12. And today my eyes are just, I think is it my left or right contact? Okay, left, can't see. Right, can't see really well either. Come on, eyes. You can do it. Today's the big day, eyes. You're supposed to be able to see things. I think it's going to be pretty useful. I've never used it before. That's awesome, Jessica. Yeah, it's a lot of people have never used Discord. It's kind of like a GroupMe. So if you haven't checked out the Discord, it's kind of like GroupMe, and you get bonus for going. You get half a point on your final grade. What? There we go. I'll put that. I think Mewbot knows the Discord link. If you have questions about the class, just let me know. Ask them. We could start doing some work. If 201 wants, we could do Canvas content. 474, 475 here. We could talk about coding. Your call. Just say, hey, could you explain this, or could you go over this? Could you go into depth on this topic? We'll do that. I'm just gonna keep vanishing and try to get my contacts to do their thing. Maybe it'll be a day where I put on my glasses. Oh, bright eyes, doing good. One of those days. Just this morning, I was like, I can't see. Let's see. I think some more. I answered all the questions in 201. I was having breakfast this morning. I got caught up on 201 questions. Well, there's a lot of 474 questions. What will our final project be about? Good question right there. I have to answer these between the stream. So many good questions. But what questions do you have right now? Might have to come back. Let's see. I'm going to focus on the stream. Who has questions? If you're 201, if you're 474, 475, does anyone want to do some 201 work? Maybe work on one of the Canvas contents. Maybe work on one of the Pearson homeworks. I want to make sure 201 doesn't get lost. It's a lot of work, and asynchronous is pretty tough. So you're going to hear me try to pull in those 201 questions. Of course, we do have 474, 475. But what questions do you have right now? It is your call. Even if it's, hey, Brian, could you lecture a topic? Could you just lecture? I can do that. I can lecture. I can do assignments. You name it. I can drink coffee too. Good coffee. My wife is a veterinarian. So veterinary medicine, because humans are gross. No human medicine. See a question right here. Oh my gosh, Michelle, my eyes are so bad. Here we go. There. Oh, come on, eyes. There we go. I was not able to attend the last 2 YouTube streams due to work. I watched the recordings. So that is awesome. Michelle, thank you so much. Michelle, good. That is awesome. I think they should help out, and you can, if you saw how they have the timestamps in there, and yeah, you can just check out what was asked, what was said. You can put it on the background, just listen to it and kind of get some info. But yeah, that's what I want people to be able to do, is if we ever do a live stream like this, and you get points for just being here. Thank you so much, Michelle. I might do some, I might come up with a question. Sometimes I do that. I'm 201. Awesome. That's, I really, like, it's kind of like, I'm not a parent. I'm in my 40s, but I'm not a parent. But, it's not like if you're in your 40s, you're required to be a parent. But I almost think of, like, my students as my kids, and there's people who are older than me as students. I've had people in their 60s. I don't think 70s as students. But every child is special to me, like every one of my students, because 474, 475 have a mountain of a task with coding. That's tough. 201 has their hard task with asynchronous. Every class has their challenge in it. So those are the challenges of the classes. I don't know, Sierra. My eyes are really not just. With clean classes, I might actually put on my glasses. In one of those rare instances. Can you go over using Oh my gosh. 2 seconds here. Oh my gosh. Here we go. Sam, good to see you here. Here we go. Can you go over. Let me make the font bigger. Can you go over using which for question 2 for lab 1? I know it pulls the positions of the numbers, but how you find the mean once you have done that? Good question, Sierra. And Mubot saying, hey, in the chat right there. So let's take the timestamp right here. Would everyone give me a second? We're going to put on glasses. Give me a second. 1 minute break. Glasses, be right back. I'll be right back. We're putting on glasses because it's not resolving right now. Be right back. It's glasses day. Be right back. 1 minute. Okay, it's glasses day. And wow, I can see. Let's do this. One of those rare instances. People are going to say, what is going on? Brian's wearing glasses. Worn them for a long time. 475. Yes, 475. Using which command? Let's go check that out. Here we go. Okay, so when we think of the which, what does the which do, Sierra? Like what, if you had to tell me what which does, what does which do? It finds positions of what? Which finds positions of what? Like always try to think about like what a code does. Which finds positions of what's? Because you're basically saying which one. So it finds the positions of the what's. So which finds the positions of the what's. Let's go right here and go to vector. Let's do this. It finds the positions of the trues. Exactly. So if we go to which and we go to vector, now before I hit enter, what will this return? So if I hit enter right here, what will this return? So this is a great way to practice coding, is to do a small example and know what it'll return before you hit enter. So I coded a vector, which is a logical vector with trues and falses. And so now I'm saying which, and I'm putting vector inside of the which function. Great job, Sarah. Right there were some points. It's returning 2. And Michelle, yeah, keep getting those points. So right here, let's throw out some 50 points. Double Michelle's points right there. Good job, Michelle, right there. So notice how it returns 2. Now, if I put another true over here in position 5, it'll return 2, 5. Now, there's not a comma between that, but it's saying the first true is in position 2, the second true is in position 5. So it's telling me the positions of the trues in this vector up here: false, true, false, false, true. You can also see it over here on the side: false, true, false, false, true. There's 5 things inside of here. That's what the 1 through 5 means. Logical means the class of the vector. So just understanding what we've created inside of R at this moment. Now, what we can use for this is we could go over to a Stat 201 survey. Let's look at some kind of more advanced ways of using this and pull up data from students from, let's go, I like survey 10 because it doesn't have names to it. Let's find out if somebody is Brian's height. Brian is 75 inches tall. So we're going to go here and we're going to go to the name of the data frame. That's the name of the data frame. And then Sierra, what are we going to put to connect a data frame to a vector inside of it? And there's a hint if you click right here. So a data frame is like an Excel spreadsheet, and that's the name of the data frame. It looks like an Excel spreadsheet when you look at it. It's just like a bunch of values. And then we want to get to these vectors inside of it. What do we put to connect a data frame to a vector inside of it? What would we put right there to connect a data frame to a vector? Great job right there. Sierra's already got it. $height. When you type $, you get the autocomplete and you can just click height right there. And here's the heights of everybody. So that's just that vertical vector right there that we're looking at. When you think about it, a data frame looks like an Excel spreadsheet. Just think about Excel. And then we're taking this vertical vector right here and it kind of wraps around the screen. It's not vertical anymore. It's just wrapping 72, 62, 63, 72, 62, 63. It's just important we know what we have. Now, I want to find out if somebody is Brian's height is 75 inches. We need to do logical equals 75. So what do we do right there, Sierra? What do we do right there? And we're going to do some stuff right here with this. We're going to do some pretty crazy stuff. Tell me if it answers it, and we'll probably even do the exact one you're looking at if you didn't get the answer, Sierra. But I want to find out logical equals is Brian's height. Logical equals 75 inches. Logical equals. What do we put for that? Logical equals. What is logical equals? And I say two words. So whenever I talk about logical equals, like to test if something is equal to something, I say logical equals. It's like a logical test. And remember, I don't know, or I can't remember is a great answer. Sierra might know, but you can always be like, just shows me you're falling off. You're like, it jumped out of my, yes, no, Sierra, you got it, 20 points. It's equals. That's why I say logical equals, because it's two equals. Kind of helps us remember logical equals. Because if you just do something here, we'll do the 75. That's going to tell us if somebody is 75 inches tall. You can see that person is right there. Person 661 is 75 inches tall. If you do something like Brian equals 5, then that sets the object Brian equal to 5. But if you do something like Darren equals 5, that is going to check the object Darren and see if it's logically equal to 5. So it's important to know the key difference between equals, which is the same as doing a left arrow. So left arrow is the same as equals, but equals is a logical check, and this won't run because it'll say object Darren not found or something like that. There it is, object Darren not found, exactly what it says. So that was doing a logical check where this first one is saving into, and I usually like to say save into with a left arrow because that's two words also, save into. Into is one word, right? So that saves into that. So just understanding the key differences between the code, kind of taking off those cobwebs in our mind to get us ready. So now we are going to take and let's store this Brian height. So now we have a vector of Brian height right here. Does that make sense? Everyone here has Brian's height. Now what I want to do is I want to take the people who have, or I want to find the positions of these people. So let's say that. What should I do to find the position of the people who have Brian's height? What should I do to find the positions of the people who have Brian's heights? We're just kind of going back now and reviewing the which function. So what should I do to find the people who have Brian's height? I know 661 has Brian's height, person 661. We could go look at that and go down here to person 661. And there they are right there. There's 661. We saw it because when we looked at the screen right here, that was them right there. That's why we get the true right there. So how do I find these positions of the people who have Brian's height? So we're just not a big command right here. What will we do to the Brian height vector to find the positions of the people who have Brian's height? So this is the theme of the question, because which gives you the positions of the trues. Right now we have a true and false vector. And so we can go, like right there, checking points. Go right here and go which, and go Brian height. And with this right here, there's the positions of the people who have Brian's height. And what's really great about this right now is we could find out how many by taking the vector right here and going the length of the vector. And that is, there's 20 people who have Brian's heights. There's other ways we could do it too, but we can just see how many trues there were by doing it that way. But you were asking about specifically about a mean question. I might even go cheat and look at your question here. I know it pulls the positions of the numbers, but how would you find the mean once you've done that? Now be careful. If we wanted to find the mean weight of people who have Brian's height, So we have, let's go right here. I'm going to make this. So Sierra, what do I have? And Lindley, so good to see you here. Feel free to ask any questions you have, especially 201. Let me know. Sierra, what is stored in this vector right now? What is stored in this vector right now? So just look at the code and think about what I named it, because I tried to give it a logical name, and what is currently stored in it. Lindsay, so good to see you here from former upper level classes. So good to see you, Lindsay. Someone asked today, Lindsay, if people can just swing by and hang out, and I said, definitely. I said we have people swing by all the time. Yeah, we're doing a 474 right now. Ask a 474 question, definitely. Ask it right now, and we'll put it right next. The positions of the people with Brian's same height. Exactly. So now we know where the people are located, right? So now I want you to tell me, what is this code finding me right here? What is that code? So the square brackets allows you to assign positions. So this is person one's weight. The first person in the survey weighed 160. So explain to me what code line 9 is doing. Yeah, exactly. Just come here, hang out, just chill. What is code line 9 doing? It's the what's of the people with what's. It's the what's of people with what's. And I'm going to look to see if I answered your question directly. We might even just do it. We always give a lot of help right here. Leela, good to see you here. Drop any questions you have. We got another 474 lined up after this, so give your questions. How much with the people with the same height weigh? Exactly. These are the weights of people who have Brian's height, because we're getting from the weight vector only the positions of the people which match Brian's. And Karen, good to see you here. So now we could get the mean, and this would be the mean weight of people who have Brian's height. Does that make sense? So we could say, like, on average, kind of people who weigh or people who are 75 inches tall weighed 196. So we can find the mean weight of people who have Brian's height. Did you get the answer to your question? I'm probably going to pull up. It's about assignment. I want to try to net a key screen notification required update on the string I package. And I have installed the update at least 4 times. Oh, no. So you did we might need to hop on a call. We might need to hop on a call. Have you updated your R, Lindsay? That's a really good, tough question right there. The updating of R. Let me, I'm going to pull up Sierra's question, and we might need to hop on a call between classes, Lindsay. And we can share screens. Are you on the Discord? Because that's one of the quickest ways for me to, like, take a look at your screen and see what's going on. Really good specific question right there. My suggestion right now, as I go check, you have to the newest version, probably might have been part of the issue, and then you did install.packages string I. If you're on the Discord, send me a screenshot of what you see after you do install.packages string I's. Tell me if it gives you any sort of error. You should click. Go ahead and click the restart R button. Like, do what I do right here. Try the install.packages restart R. Tell me if that works, and send me a screenshot. See, okay, see, I'm getting this. Do you want to install the source packages which need to be compiled? Yes. That's probably gonna. Okay, good. So tell me if you see. It might even do more. You should see. Okay, this is good. Send me. Oh, it's gonna do something crazy. What have I done, Lindsay? What have I done? I'm gonna try to pull up Sierra's question here as we do this. To take a look. It's doing like a source. 2 hours later. Okay, we're going to look at Sierra's question right here. It was question 2, I think Sierra said. And if you're 201 or anything, let me know. Sam Cook asked with 201. Thank you for tagging that, Sam. Some points right there, 20 points. I was wondering what all the jump files in the modules under each chapter are doing there. Let's talk about that next. And it says it was successfully installed, but it won't knit. And it just keeps giving you a string I. Lindsay, worst comes to worst, I'll knit this for you, and we'll figure out what's going on. Lindsay, since you've told me this, I'm going to give you full credit no matter what. I will trust that you've done all the work. And yeah, so we'll get that done. So sorry about that. I shouldn't have. Sierra, were we able to answer your question, Sierra? I'm loading up some stuff right here as we do this, but because I've done the stuff from maybe, let's hear, we're going to hit stop. Okay, I hit stop. Hopefully, our session aborted. I'm destroying things. Yeah, we'll probably need to do that. I destroyed my R. Oops. And then we'll talk about Sam's question right here in just a second. Let me see. Remind me later. I need to update all my stuff. I get to update every semester. It's fun. Okay, let me download the R data and the RMD. And let's take a look. Yes, I want to load. There's the data. And which question was it, Sierra? I think you understand. Awesome, Sierra. Let me know, or other people let me know if we don't get a lab question done for you, and we'll get it done. Lindsay will hop on a Discord. And let's go over to Sam's question right here. I'm going to do a change of screens. Okay, 201 about the jump files. Thank you so much, Sam, for asking that. Put on a little music right here. Do a time here. We're making the sure that. Yep. Check out, and Karen, thank you so much for asking. So good to see you. KP, right? So good to see you. It's remind me, it's KP, which you prefer to be called, right? Or you said it's okay to call you KP. I think. Let me know, because I always make sure I get everyone's name right. 2340 stat 201 jump files in modules. Let's go take a look at that stat 201 jump files in the modules and find out a little bit more about that right here. Here we go. Awesome. So good to see you here, KP. And every lecture for Stat 201, if we go over here to the Stat 201 page, it's one of these. Stat 201 Summer 2022. And so with this right here, you'll notice we go to the modules, and the modules have jump files. Now, the jump files are not required. Here's formula sheets for you for the test, so make sure to use the formula sheets. Practice exams for the test. So a lot of people asked about those. So those are also on your, they're not available. You know what we'll do? Boop. Now you can see them. Hey, topics for, let me make sure. I think so. I think everything should be good right there. Should be good. Nice and easy to see some review material. Okay, so let's check out the Apple Store data right here. I think we just need to go over here. If you have Jump installed, it should download. I'm gonna make sure I don't have anything open in Jump currently. Work with a bunch of different data. I need to update my license, but we're good for another 33 days. And now we open up the Apple data. So to Sam's question right there, and thank you so much, Sam, for asking, the data that you have access to is basically just a bunch of files to either practice or the ones we use for examples. So this is a Jump spreadsheet. With the Jump spreadsheet you're seeing right here, we really have two types of variables. What are the two types of variables? Good review for anyone in any class. What are our two types of variables? I'm going a little lecture right here. What are the two types of variables? Does anyone know? Or some points. Good review for 320, 474, 475, 201. We have two types of variables. I guess there's more way data can be. You can have like images, but we really talk about two types of variables. Categorical and quantitative. Sam worked some 20 points right there. And you notice how this is blue? Well, it's actually an identifier, because identifiers are kind of unique for each and every observation. I think this is also an identifier too. We could kind of test it by going right here and looking at the distribution of values. Ooh, maybe it's not. Let's go to, watch this. We're going to see if it's, let's go here to nominal. And let's see if it is an identifier. If it's an identifier, it should not repeat ever. Yeah, that's an identifier. You see how this never repeats? So it's what is it in the Apple Store, the ID of it in the Apple Store, and none of these, you can tell, none of these go beyond. If we went to the table down here, it's all going to be observations of one. So an identifier will not ever repeat. Sometimes they can be numbers, and Jump will think it's quantitative, but the real quantitative value here is file size. So we could look at the file size of all of these different softwares in the Apple Store. We could look at the category that it's in with games and such. Let's go right here to analyze and go to distribution. I have videos for all these, but let me know if I need to slow down, clicking some buttons right here, and go to file size by double clicking it and click OK. Now, if you notice, this is a very what skew distribution, right or left skew. Is this right or left skew? And there's an easy way to remember if it's right or left skew. I'll tell you the easy way. The easy way to remember right or left skew, so don't worry if you get it wrong, we'll practice. Draw your little monster man. And the way to remember, Jessica, good guess, 20. We get more points. It's actually right skew. So the way to remember this, you ready? Right to the high, left to the low, whatever way the Monster Man's tail goes. Right to the high, left to the low, whatever way the Monster Man's tail goes. Right to the high, left to the low. We're some 50 points right there. Good guess right there, Jessica. Right to the high, left to the low, whatever way the Monster Man's tail goes. It's just the way I memorize it. If you draw your little Monster Man, you're going to see which way his tail goes, her tail, its tail. I don't know what the Monster Man, just call it Monster Man. It's alliteration. But remembering that right there. You can get tricked, though, because I've had students see test questions that look like this, and people will say that this is left skew. But tell me, the tail of this is going towards the what side? But be careful, because sometimes people say, well, that's left skew. If I turn it down, it'll be to the left. Don't say left or right now. Say that those values are skewing towards the what side, like they're being pulled out towards the this side of it. Don't say left or right, because this is right to the this, left to the this. But I'll show you why this mistake happens. This is the same data. Both pictures are the same, just displayed. The top, the high side. If you turn it to the left, the number line would be reversed. That's a common mistake, is just drop this way just drop it down, but your number line would be reversed. If you have the number line properly aligned, which you see here on the right, once again, this is the same data. It's just one of these is horizontal, one of these is vertical. If you have it where the numbers go from low to high, then you will see it's right skew. Just make sure if you do this one right here, you don't turn it this way, because numbers don't go in reverse order. Properly doing the numbers, it is always right to the high, left to the low. I've just had people with the one on the left make up, Zachary, good to see you here. So good to see so many people. I'm wearing glasses today. Crazy day. I told people, I said people drop by, say, hey, just swing by, say, hey, what's up? We throw some points out. So that is a quantitative distribution. Does anyone know another way I could display these numbers? We could use a histogram, or what else could we use to display this data? It's up here, actually. You don't have to use a histogram to display the data. To display quantitative data, you don't have to use a histogram. You could also use a what? What's up there at the top? And you get a little hint if you look at this. Close, Michelle, good guess. Scatter plots are bivariate quantitative. So that's not a scatter plot exactly. If you have a scatter plot, we would need something like height and weight. So scatter plots, just so you can see right here, a scatter plot is when you have something like height. I should do it inside a jump, right? Let me open up a data set inside a jump, because we're talking 201 right here. I'm going to be good. I'm not going to use R. Let me throw some more points. Good answers right there. Scatter plot is two quantitative variables. So let's go to the scatter plot chapter, which you can do it for correlation. We'll go to the bake time and test scores data set. And we need two quantitative variables. So you see how we have the baking time right there, which is quantitative, or baking temperature, excuse me. What temperature was the cake baked at, and what was the score of the cake. And when we run fit y by x, Lindley, you got it right, Lindley, we would get a scatter plot right here, which technically we should do the y variable and the y. That makes sense, right? So if you notice, this is a scatter plot. A scatter plot is two quantitative variables. But Lindley was correct that we could do one variable and get a box and whisker. You can do the graph option. And if you're looking for the important things right here, here's the important note. Are you ready? A box plot, which this is, displays one what variable. A box plot, so if you're taking notes, a box plot displays one what? A box plot displays one what? Good note right here to take. A box plot displays one what? There we go. Really? A box plot displays one what? A box plot displays one quantitative variable. Variable is correct, one quantitative. A box plot displays one quantitative variable. Do you see how we can see the maximum temperature a cake was cooked at was 675 degrees? The minimum temperature a cake was cooked at was 100 degrees. I don't know what people are doing. Those didn't get good cake scores. But though this is one quantitative variable. What else could we have made from this? This is Brian reviewing. We didn't have to turn this into a box plot. We could have made it look like a what? it didn't have to be a box plot. We could have made a what instead. Instead of a box plot, if you can read the small writing up there, instead of a box plot, we could have made this into a what. It's a good review. Quantitative variable, great job, Michelle. Histogram, and that's what we saw first. So it could have been a histogram. So a histogram also displays, not as, this is more of a uniform histogram. It's really flat. I don't like that it's in vertical layout. So I would fix this right here by taking this and bring it down here to the x-axis and put it across the x-axis. So this is a histogram right here, which has the counts of the observations in the bin. It's a little bit different from the box plot. One of the great things about the analyze distribution option is if you do the variable here, you actually get both of these. Notice how you can see the box plot up top and the histogram that we made right there. So you're actually getting that box plot we made previously, and you're getting a histogram. So it's displaying it two ways. It's just a double way of doing the data. You get your histogram and you get your box plot. Histogram shows you how many observations are in each bin. As you can see here, there's 5. We could add the count access. But the keynote for you to take right now, if you're looking at what I'm doing, you're saying, what am I learning? Is that histograms and box plots are interchangeable. It's kind of just picking which one you like because they both display univariate quantitative data, which means they display one quantitative variable. What was the temperature the cake was baked at? Are there any questions on this? And this is how you use the jump files here. I've got walkthroughs on a lot of these. I put a lot of them into the modules for you to see what's going on. Let me know what's going on. What are your thoughts? Ask questions if you got them. And Sam, great question. Sam, some more points for just asking, bringing us down this little working with data experiment right here. But we can do a lot of things with data. We can do so much. We'll see what more questions there are. Might try the contest. Oh, shucks. No, it's great, Sam. Just whatever you're thinking, whatever you're working with. If you'll want, we can do a Canvas content. We can do Canvas content too. It's coming up, right? Always feel free to jump in here and be like, hey, Brian, I'm working on a Canvas content. Can you maybe do one? Maybe go through one of those Canvas contents, work it. Maybe see a few versions of it. Those are test questions. Or you can all totally stuck, especially when we get to the waiter-waitress question. Oof, that waiter-waitress question is I'd say one of the hardest questions of the whole semester. And people often ask about that. Let's see. So Sam and others in 201 or 320, 475, 474. If we were to talk about something like the category a game came from, what graphic could we use to display category a game came from? What graphic could we use? We could display this variable with a what? We could display that variable with a what? What kind of graphic? Like we already talked about scatter plots a little bit. Pie chart. Michelle, 20 points right there. Yes. And a great way to remember this right here is you can make a pie chart of your favorite bars and you can make a bar chart of your favorite pies. So let's go here to analyze distribution and let's go to categorical, or let's go to category, which is categorical. And this is a bar chart. Now we didn't get the pie chart till we go over here to graph builder, and we can put it right in here and make it a pie chart. Oh my gosh, that's a lot of categories. Label value. Whoa. Let's go to label percent. Oh my gosh. And then you try to go over here and make it look pretty. Pretty right there. It's got so many categories, we're probably never going to make it look nice and pretty right there. We tried. We attempted. Turns out most things are games. Are you shocked that a lot of stuff in the Apple Store, over 1/3 of stuff is games? This is really nice. We got education right there. We got entertainment and photo and video. Let's see small categories. Books in the iStore. Food and drink. There's food and drink on the odds. Next time I'm hungry, I'm going to go over there and get some food and drink on the Apple iStore. Didn't know that. But we see a bar chart and a Pareto chart. Bonus question worth 50 points right here. What is a special case Pareto chart that has... What is a special case bar chart that's been put in order? What is a special case bar chart that has been put in order? It's a special kind of bar chart that has been put in order. So we're just displaying the same variable right here. Now I want a bar chart that has been put in order. That's a bar chart. That's a pie chart. It's the same data. Pareto, Layla, great answer right there. Pareto. That one's harder to find. You have to go to quality and process and go down here to Pareto plot. Pareto, think of it as put them in order. Pareto, put them in order. We go to category and we drop it right here. And here's the Pareto chart. So now we've displayed, and really we've got a lot of categories. Usually I don't use something with this many categories to it. But now we have every single graphic we really talk about. I guess frequency tables aren't on here, but this is kind of the meat and potatoes of it, where you have the same thing. Here's the bar chart. The Pareto is a bar chart that's been put in order. And here's a pie chart right here, which looks like a pie. So remember, you can make a bar chart of your favorite pies and a pie chart of your favorite bars. And a Pareto has been put in order. Any questions about the material right here? We're just kind of talking about variables. This is a categorical variable because it's what type of thing is it on the iStore? What category is it? Categorical variables category. What questions are there? Let me know. I don't start the next class till noon your time. I'm going to try my contact scan after that. For working with JUM, can we use any data in the modules? Of course, of course. Yeah, and it's kind of neat to practice with this right here. If you have any questions, let me know. You can easily message me. You see, I already have 6 messages on Discord. Discord is super quick to message me. I'm going to try to catch up on the... And Isaac, so good to see you here, Isaac. I'm going to try to catch up on the messages I have from other classes. I got caught up on 201 this morning. So many good questions. So many questions on the 201 Discord right now of like, explain a little bit about the test, explain how the campus contents are, but just people asking lots of questions and people saying, oh, this is really great. I can see kind of, what's going on. So, and you can reach out to me for help. You can talk to other students. Just a really great social place to go. We'll go over to the main screen. Who's got that next question for us? Who has that next question? As Brian debates when he's going to get coffee number 2. I started drinking coffee at, I think it was like 10. They had it. I would go to church and they would have coffee out. And the people in like their 60s and 70s were like, you're going to stunt your growth drinking coffee, a little 10-year-old. And I'd be like, it's more sugar than coffee. True. And I don't know, if it's stunted my growth, I'm probably happy about that. My back hurts all the time. If you know anyone who's like 6 foot something, our backs just hurt. We're in constant back pain. It's no fun. And if coffee stopped me from being 6'7" or something ridiculous, nothing wrong with being 6'7", but quite fine with where I'm at. And if it stopped that, then thank you, coffee. Who came up with that idea that coffee stunts your growth? I heard that all the time growing up. They stopped saying it to me when I was like a little bit taller. Like by the time I was like 15 and I was like 6'1", 6'2", or whatever, they stopped saying that to me. They stopped saying, oh, it stunts your growth. I don't know. They're always like, I guess I was wrong. So it probably does now. He's one of the ones that didn't have him. Being tall is such a burnout. I can't tell if that's sarcasm or serious. It's interesting. There's some cliches to being taller. Like I've been at the grocery store and had an old lady be like, "Excuse me, sir, can you get that off the top shelf?" I've had that happen probably 2 or 3 times in my life, and you know it's happening. You know it's happening because you walk down an aisle. And when you're walking down the aisle, the person like looks at you and they kind of look away and then they look at the item and you can tell they're contemplating it. Because it's just like when the 3rd time it happened, I'm just like walking, I'm just like, doo, 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 doo. So you walk down an aisle and then the person just looks at me, looks at this item, and I was like, are you? They they see you walking out of the aisles and they're like, it's one of those tall people. We gotta get him to take that down off the shelf. It's pretty crazy. It's pretty funny right there. It is true. I'm just in awe of giants that walk. Well, I was out yesterday and I saw someone who was like 6'8" or 6'9", and I was like, holy man! I try not to be like, whoa, but when I see someone who's like a good half a foot taller than me, I'm just like, whoa, they're tall. And I guess maybe sometimes how people look at me, but I'm 6'3", so it's like, it's like, am I tall? Nah, it's one of those like, It's funny because if you do the Z-score on it, even in our class, I have a Z-score of 2, which means I'm kind of an outlier. But someone who's like 6'6", 6'9" would have a Z-score of 3 and 4. So we could talk about z-scores here. Z-scores are how many standard deviations above or below the mean you are, which gives us a metric to talk about how unusual something is. Let's do that. Let's do a little. We just went to one of those topics right here. Let's talk about z-scores. You'll be covering it at the end of the week, I think. So let's do Stat Tool 1. And what is a z-score? Stat Tool 1. What is a z-score? Let's hop over here to the main screen. Okay. So a z-score sounds really complicated, but I promise you, you already know what it is. Your parents, they're awesome. Let me just say that. I don't know them, but they're awesome. Your parents ask how you did on the test. You tell them you did great. Okay, well, great is subjective, right? Okay. Turns out you made a 70. Do you think your parents should be happy with you? People's thoughts on that. You made a 70. We're just saying facts right here. You made a 70. Do you think your parents should be happy with you? You said I did great. Say, so what'd you make? You said I made a 70. I did great. Parents are really confused by that. Sierra says no. But what does all data need? Ooh, this is good right here. This is a Stat Tool 1 question. All data needs. Who can fill in this blank right here? This is a question. Ooh, Sam, good. Sam, 50 points right there. Sam, you're on the right track. And Sierra got that too. All data needs context. It's a big thing we say throughout every one of our classes. All data needs context. So 70. Let's do two contexts here, right? You tell your parents you did great. Well, Sam said, we call up Sam, and he tells our parents the average was a 50. Now, what could you tell your parents if the average was a 50? You could say, I did what? Just say, I was this above average. So kind of complete this sentence right here. Sam's like, oh, well, the average for the test was a 50. We can call this quantity mu. We can call our score. Let me change the colors. What could we say about this? So we call in statistics mu for mean. Make it look like a pretty mu. There we go. And this is the observation. There's the observation. We could tell our parents we were what? We could say, I did this. We could tell our parents what? And there might be some interesting scenarios to think about here. Because what if the average was 50, but the exam scores looked like this? A symmetric distribution. You were 20 points above average. Great work right there. Great answer, Michelle, right there. Yep. And now I want you to think about this. Here's us. This is us right here. And the scores on this test were basically, there was one person who scored a 30. There was us who scored a 70, and then everyone else got zeros or hundreds. This would average to 50. Does that make logical sense? Like, we averaged with the person who got the 30. And so does that make sense right here, Sam, that now we're 20 points above average, but there were tons of people who got 100. Like, if people showed up, they basically got 100, and for some reason we just didn't answer like an obvious question. The average is still a 50 here, but we're kind of like, you know, there's a lot of hundreds. So I don't know if I'd say we did great. We did above average, but in this instance, maybe we didn't do great. But in truth, I would say the data probably on most tests looks more, and you might need to be an upper level class to know this term, the data would probably look more Whatley distributed. You maybe heard this before. We do some A+ drawings right here. The data probably would look more Whatley distributed. I would say the data probably has more of a what shape to it. Who knows the name of this curve? Chapter 5 is the name of the thing. This is a very tough chapter. Bell-shaped normal, that is correct. We call this the normal, the unimodal and symmetric. It has one mode, unimode right here, and it is symmetric right here. So now the question becomes, where are we on this curve? Well, we know we're 20 above average, right? So if this is hypothetical scenario number 2. You going to show me the rest of my drawing? No, guess not. There we go. And so here is the 50. And maybe we're over here. Just tell me visually, our grade is at the what of the class. Just visually speaking, our grade right there is at the what of the class. Just don't even think statistics for a moment. Just think visually. If these are the observations, like the observations are the people, the amount of people who are in each bin, we are at the what of the class. Don't even think stats. Don't even think stats. We're at the what of the class right now. Our grade is at the what of the class. We're at the top of the class right there. See our grade answer. So we know we're 20 points above average. There's the mean. Here's our observation. Now the question becomes, the top, the upper percentile, right? We can even figure that out statistically. Now, what if I told you that the standard deviation was 5? Let's do a new color. And this is how we do a z-score. So there's the mean. 1, 2, 3, something. If the standard deviation is 5, you would say, Brian, your score of a 70 is how many standard deviations above the mean? Your score of a 70 was this many standard deviations above the mean. Your score, it was 4 standard deviations above the mean, which is very unusual. And so let's take a look at this visually right here. And this is what Sam was kind of going towards, is if we go and use some of our online calculators for this, which you'll use, this is a tougher chapter. If you're getting this right here, you're understanding one of the toughest chapters we'll be doing. We're actually off this curve right now because this curve only shows how many standard deviations right here. This curve only shows, remember we said the mean of this exam was 50, and then we have a standard deviation of 5, which is the units on the normal curve that you go up for 1 standard deviation. That's what a standard deviation is. So we only are 7. What's the answer? I'm going to ask something. This only shows 3 standard deviations, right? So now we want to know if somebody scored above a 70, let's say what percent of students scored above them? Does that say 0? No way. Is it not carry enough decimals? We might basically, Sam, you're off the curve. You're in the top. Would that be good news for your, like, would you be able to tell your parents that you are beyond what anyone really scored? You're in the top of the class. Would that make sense right here? If you score a 70, I'm so bummed we're off the curve. That's kind of a good thing. We're so far off the curve that probably no one scored above us. What about if we scored a 55? What would be our z-score if we scored a 55? So just using what you see on the screen right here, what is the z-score of a student who scored a 55 on this test? What would be the z-score of a student who scored a 55 on the test? So here's the mean. The standard deviation is 5. So the z-score of a student who scored a 55 would be what? So a z-score is how many standard deviations someone is above or below the mean. So this person is 5 above the mean. That's right, Michelle. Exactly. Because the z-score is right here. And let me show you visually. Excellent work, Michelle. On the normal curve, you can go below this and write the z-scores like this, because a z-score is just how many standard deviations you are above or below the mean. So you correctly identified that that would be a z-score of 1. And so what does that mean? If you made a 55, you are what? Someone who made a 55, remember this is where the mean is at. The mean is 50, and a standard deviation is 5. Someone who scored a 55 is what above the mean? Someone who scored a 55, that's a standard deviation right here. Someone who scored a 55 is what? And that's what a z-score means, because they're 1. So someone who scored a 55 is something above the mean. And that's why they have a 55, or that's why their z-score is 1. They are 1 standard deviation above the mean. Does that make sense? So if you made a 55, you're 1 standard deviation above the mean. Now, I can tell you the answer to this because I know what's called the empirical rule. It's going to be, I think, 15.84, or about 16%. About 16% of people will be above this. And there it is right there, 15.87. Great job, Sam, right there. So, Sam, I want you to think of this as 16%. I want you to tell me, this is a tougher question. You ready? what percentile is this person in? What percentile? Percentile means what percent of students are below them. Like if you say I'm in the 99th percentile of the class, you're at the top of the class, you'd be over here. So if this is 16% above, what percentile are they in? Does that make sense? And slow me down if I'm hitting you too much right here. We're doing a tougher chapter. Good guess right there, Michelle. Not 65. Good guess, though. Worth some points. So think about this. We want to find out the area below this point. This is a pie with 100% of data. So if 16% is above, Sierra, good work right there, 84% would be below. So does that make sense right here? If you see that we have 16% above and we're just rounding it to 16 to make it nice and neat, 16% above, 84% below. Does that make sense? And Sam, good work right there. And Michelle noticing the answer. Great work. So that is the percentile. The percentile right there. Yeah. This is one of the toughest chapters. And just jump onto office hours if you're stuck on it, because chapter 5 is going to be tough. You come on here and just drop the questions at any time, especially if we're doing some R coding or something. Be like, hey, I was wondering about this, and I'll edit to the notes. But this is going to be a tougher chapter. We still got some more time. Is anyone wondering about anything else? This is what a z-score is. If you tell your parents you made a 70 on an exam that had a, let's write the notes on this. So this would be written down as normally distributed with a mean of 50 and a standard deviation of 5. And thus a 70 would have a z-score of 4. The z-score for this is equal to 4 because that's 4 standard deviations above the mean. For 201, is there an easy way to calculate stuff like the mean, median, IQR besides writing out? Yes, using JUMP. So Leela, let's make that a segment. Thank you so much. 20 points. Let's do it. Okay, let me put this in here with a timestamp so people can come back later. Stat 201, calculating mean, median, and IQR easily. So let's hop over here to the main screen. So the number one thing I support for calculating these values is using JUMP. So make sure to download JUMP. I've got instructions. Do we have... Let me go grab that playlist for you right here as we're talking. And thank you for the people we have watching. So good to see you here. Let's go. I'm grabbing the playlist right now for the Getting Started. I should make links from Ubot for this. Getting Started in 201. There it is. Getting Started in 201. So if you are looking to install JUMP, you can download JUMP 16 or JUMP 15. Either is fine. Downloading JMP. The link is now in the chat. Oh, hey, Shreya. Yeah, my eyes are going crazy this morning. So good to see you here, Shreya. Hope you're doing, you're gonna be in class today, right? I think so, right? I think you're in summer semester. I might put context back in. You never know. So good to see you here, Shreya. And so what we're going to do right now, we are going to show how to calculate the mean, median, and IQR. That's awesome. It's going to be a lot of fun. We're going to have tons of fun. We're going to calculate the mean, median, and IQR for some data. Now, when you're doing a problem inside of MyPearson, you know what? Let's kind of do a MyPearson problem. I think this is going to be the best utilization of showing how to do this. You want to bring the data over to JUMP. You want the data to look like this. And what color, be careful, I'm trying to trick you. What color should the variables be if you want to calculate the mean, median, and IQR for 20 points? As I'm getting the course loaded up, what color should it be? Should it be blue or red? Hint, I had to change it to get a wrong answer. Should it be blue or red? What color should the data be? I've almost got everything loaded up. What color should the data be? Let's see if people got it. Greetings, Charles. Good to see you here. A few years ago. That's awesome, Charles. So great to see you. Got a pie right there. A pie with a pie. Awesome. And Layla got it for blue right there. Thank you. Swinging by right here saying, hey, that's awesome, Charles. It should be blue. Blue means quantitative, which is continuous. That's the way it labels it right here, where red is categorical. So we want it to be blue. So if you have a blue variable right here already loaded into JUMP, you can go to Analyze, Distribution. That's Analyze, Distribution. Click the top right there. It'll be at the top on a Mac. Analyze Distribution. And once you do this, you want to double click the variable you're interested in. And now you will get the values by clicking OK. You can figure out the IQR. I'm going to click the top right over here and click stack. I'm trying to go slowly. Or you can pause this, but I do want to go slowly. And click stack. I just like the horizontal layout to it. With the horizontal layout right here, you can see that we have the values of the mean, the median, and the IQR here looks to be about 265. No, I'm wrong. Am I right? I think it's 265. We have to subtract Q3 from Q1, but watch this. If you're worried you did the math wrong, you can go right here to the customized summary statistics. That's this red arrow right here, customized summary statistics, and click on the interquartile range right here. And then click OK, and it's 265. I did do it correctly. Q3 minus Q1 is the IQR, the interquartile range. And you get all the values in here, the mean, the standard deviation, just with a few clicks. So super helpful. I'm pulling up an example right here, I believe. Let me go. It's chapter 2. Great job. Already on chapter 2. Love it. And let's go right here to the chapter 2 homework. And we're going to pull up a question here that has us find the mean, median, and IQR. And always feel free to drop in those questions. Say, hey, I'm working on this one and I need to find it. This is on the shape of data. No mean, median, IQR there. Here we are. This should be good. Find the median. We've got 11 championship games. Now, you can put them in order or, cross your fingers, everything should work properly. This one does work. There's one I might need to fix. I think that's a problem. Let's copy to clipboard. Fingers crossed. Copy to clipboard. And now we're going to copy. Now that we have this copied, we're going to go over here to jump, and we're going to go to File, New, Data Table. File, New, Data Table. File, New, Data Table. With File, New, Data Table, there's no column name on this one. A column name, when you copy it, will be at the top. If you see a name up here at the top, which there's not, a name would be like a variable name, like if this said points or something, that would have a column name. This does not have a column name. So when we copy it, we will paste it, edit, paste, but we don't have a column name. So we're going to go to paste right here. Now, one of the things you can do to check your work if you had to do something by hand is you could sort these. Since there are, let's see right here, there are 11, so there should be a middle number right here. So the middle number right here is going to be 55. And I'm wondering, I think, does this one have an issue? Let's find out. The middle number is 55, so that is the median. Let's go right here, put this over here on the side. This is how I would do it if I have to do it by hand. The middle number right there is 55. Good. Because 5 numbers above, 5 numbers below. Now it wants the quartiles. Now, if you look right here, we have 37 is the lower quartile. If you think about this as a lower data set down here, the middle number of the lower data set is 37. Oops, got to type it properly. Good work, Sam, on those points. And then what is the Q3? Can anyone see what Q3 in this data set is? Can anyone visually identify what Q3 in this data set is? What is Q3 in this data set? What is Q3 in this data set? What is Q3? And if Jump ever tells you you get something wrong, let me know, because this one sometimes has issues, I think. If for some reason you work it in Jump and it says like you got it wrong, let me know. 65, you're right, Sam, right there. Because I think this one, there is, I could tell you, oh, that's it? That's all that question was. That was a quick one. I thought it had more parts to it. Here we go, part 1 of 6. Okay, now let's go ahead and find for this one right here. Copy to clipboard. Copy. And let's go right here. Let's paste, edit, paste. It did not have column names. Now we're going to sort this again. This is good practice if you have to do things by hand right here. I do suggest using Jump. There's 10 data points, so there is no middle number. So now, although there is no middle number, the median is still pretty easy to find for this. Because if you divide this up into 2 equal data sets, you have to what the 2 middle numbers now. Since there is no middle number, you would have to what the 2 middle numbers right here. Since there is no middle number, you'd have to what the 2 numbers. If there is no middle number using the median, you have to what the 2 numbers. If there is no middle number, you have to average, exactly. So you got great job right there, Shreya. And there's 2 750s, so add them and divide by 2. Exactly, Layla, great work right there. And so you see 750, 750 at the center. Now, on the test, we don't make you find Q3. Oh, the mean? Well, we got to find the mean. I don't want to add everything up and divide by 10, so I'm going to go here to Analyze Distribution again, double-click the variable of interest, and click OK, and then click the top and click Stack right here, and there we go. So now there is the mean of the data right there. I'm going to do an advanced thing in a moment. So stay tuned, 474, 475, because I'm going to talk about this at an advanced level too. The mean is 860. There we go. What is the median? The median, and it better not get mad at me, is 750. Brian might be making some changes right here in a moment. Is it going to say Q1? I'm going to look over here and cheat. Q1 is 550. Jump is saying Q1 is 550 right there. That is Q1. 1 quarter is 25 cents. So remember 1 quarter. We're at the first quarter right there. Check answer. We're good on that. What is Q3? Now jump. Q3 is 1150. This is where jump. Please tell me if you get this wrong. I will correct it for you. If you put in 1200 because jump told you to, please tell me. I think it will get mad at us. And I'm going to explain why this happens here in a second and why it makes me very mad. If you got that wrong, please let me know. I'll refund your points. Just say, hey, Brian, it counted me wrong. You get the points right back. I'm going to go into a little rant about that in a half second. The range of the data, even if we don't want to calculate it, Jump will do it for us. Customize summary statistics. I wonder... I'm going to talk about why it does that weirdness in a second. I'm going to have it calculate the range for me. Is range on here? Min, max, range. There it is, range. And the range is 850, max minus min. We'll get it done that, but we can ask Jump to do it. Brian's going to go on a rant. IQR is the distance between these two values. Can anyone show me the mathematics? This is the important thing to know. I need some help navigating Discord if you have time. Oh, definitely. Yeah, maybe we'll end a moment here soon, and I'll jump on Discord and talk to people there. Yeah, might do that here because we have 27 minutes for class, so might end just a few minutes early. So stay tuned, Michelle. We'll probably jump on Discord and talk there. Have you gotten signed up? Who can show me the mathematics for finding the IQR right here? Like, what is the math for finding the IQR? So the IQR is Q3 minus Q1. That is the range of the interquartiles. So what should we do mathematically here? Great job, Sam. That is what it is. It's Q3 minus Q1, the distance the two quarters, our first and third quartile, are away. So we're just going to go right here and take 1150 minus 550, and it's 600. Just check your mathematics. And there we go. And now let me give you my rant on this. And great job, Sierra, right there. Practicing, we love it. Now, here's what's weird. This is why sometimes stats makes us crazy. Let's go here to data, concatenate a vector. Let's do a trick. Nope, wrong buttons. Really? There we go. Okay. So now we have a vector. The 10 observations have been brought here into R. With this, I want to show you when I go to quantiles and you put in the data, you get these quantiles. But watch this. It's type, right? Yep. If you look at what we're getting right here, we're getting different answers. Because the way in which the quantiles are calculated, I think there's 9 ways. The way in which the quantiles are calculated differently by different statisticians across different time periods. It's like the multiverse of madness right here. So what are the correct quantiles? All of them and none of them. Because statisticians have different ideas of how to calculate where the quantiles are at. And we can read about this if we really want. If we're as nerdy as Brian, we probably have read this. I've read it. I got problems. So here's all the different ways over here on which the quantiles are calculated. And I think Mike Pearson, I can't remember which one they use, but there's a discrepancy sometimes. Please let me know if one of these discrepancies caught you. But this is why sometimes you're seeing things like 1150 versus Jump telling you 1200. None of those are wrong. None of those are right. It's just statisticians coming up with different ways of calculating where the percentiles in the data set are. You can see lots of different answers right here. A lot of them converging around these same ideas, but it drives me a little bit crazy that sometimes there's a discrepancy. If you got something wrong and you think you got it right, just let me know. I'll correct it like that. I'll be like, get your points back. Just let me know. We don't go this in depth. It's just that different statisticians have had different ideas on how to calculate these things, and sometimes my Pearson doesn't listen to them. That's the sad news right there. Any questions right there? And does that make sense? This one a little high level right here. Sierra for 20 points. What am I changing right here? I'm changing this what starts with an A. I've added an additional what to this function, and I'm changing it. So this is the function as normal, and now I've added an additional what to this function. So here's the function normally, and there's me specifying a new what in it. I've added an additional what argument right there. Sierra, you know that. Great work right there. So it's just another argument, which is more instructions to say, find me the quantiles of the data, but do it with type 1 calculations. So I'm just saying, you know, we want the quantiles, and then here's the type of the way we'll do the calculations. Good work. Any last questions right here? I'm going to go probably put my context back in. You need your eyes, you know. They're very important. Let's head back over to the main screen. So much fun stuff right there. I just find it so interesting what we can do with data. It's just an endless world of fun and interesting things that we can investigate and change and find answers like that. If you can't tell, I love R. If you want to do R for 201, let me know. I might have 1 or 2 students checking it out. You're not required, but it's a lot of fun. I'm going to go and probably jump to the Discord, answer some more questions between the classes right here. And if you're on the Discord, let me know. We can help out with it. Okay, so yes, I did sign up for the Discord. Maybe it looks a little bit different on my phone versus computer. Yes. Oh, huge suggestion, Michelle. Download it to your computer. I think it's great on the phone and everything, but on the computer with it downloaded, I think it's really great as a standalone app. So I highly suggest downloading it. If you want, does anyone want to say hey to the stream right now? Let me turn off the music. I'm going to hop down here to, let me go to one of the group rooms. I'm going to go into group room. Let me go to group room 2. Okay, I'm here in group room 2. I'll let them know I'm live streaming. Maybe I should have gone to a stage. Save changes. We'll see if anyone joins in. I'm in a group room right now. Oh, Michelle, we are live streaming right now. Michelle, do you want to say hey to anybody? Or we're live streaming. I'll probably hop off the internet here for a second, but we're currently live. You might need to turn off. Oh, they jumped out. I might go over to a stage or check it out, but we'll see. We'll end here in a moment. But looks like people are figuring it out. You're welcome, Leela. It's so good to see you here. Well, there was feedback. Yes, if you have on the microphone, I'm going to leave the stream. So I'm going to go only over to the Discord and leave the stream. Join me there if you want, and we'll say hey. Leaving now. Bye, everybody. Bye. I think I just got the outro screen up now. Ah! Bye, Jessica. Bye, Sam. Bye, Michelle. I'll be over on the Discord. Bye.